Welcome back to the bench. Today we are taking another look at the Kronas, some type of 2-channel analog to digital converter for the C64 or C128. According to this, it has a range of 128 millivolts to 12.8 volts. Whether this was to actually measure voltage, I presume. I don't think it can put out that kind of voltage, but who knows. So what I'm going to do is I want to tear this down and do a full reverse engineering of it, and produce a schematic from that so that you can better analyze what this thing was actually used for. I've already had this in pieces in a previous video, so the jacks are already desoldered. So we have the circuit board. As I said previously, this looks like some kind of small production run, because this is just pretty much bare copper, double-sided board. So we have to remove the chips in order to see all the traces that are running underneath them and where they go. The passive components we don't need to take off, because we can pretty much see under them where they're going. We just need to read off the values once we've had a look at everything else. So let's get these chips out. Now these two chips are socketed, so we're going to have to take the sockets off. So yeah, this is the ADC 0803 LCN, so that's definitely going to be our main analog to digital converter chip. So let's take that one out first. The sockets will have to come off as well. Obviously we can't see what's going on underneath them, although it's probably easier to see what's going on, easier than it would be for a chip, but even so. Yeah, they're big thick sockets, so you can't really see if there's anything going to or from those pads. There's definitely something going. I mean, that could just be a ground plane that's going underneath. All the main connections are probably going to be on the bottom, but you just can't tell. You can't see any of the traces, whether this, yeah, because here you've got traces running through here, so it's probably connecting to this pin here. You could probably trace it out, but I think it's simpler just to remove the chips and the sockets, and then you can just follow everything, and then we can just put these back into sockets afterwards. I don't think there is any need to solder them back directly onto the board. Hopefully it's not going to take too much of an issue to get this out. I'm going to use the solder now, not the desoldering station, because yeah, I think it's probably going to be okay taking out the old solder sucker. See, Daisy, that went through a bit easier than I thought it was going to do. Well, that's a few bent like between friends. Okay, so get a bit of flux on there. Let's see if we can get that socket off. Oh, it's rocking around a bit. Do we have something soft to put it on? Yeah. Should make it slightly easier. quick look, see how those are doing. Oh yeah, they're coming off nice and easy. Yeah, I lifted one of the pads already, which is why I didn't want to use the desoldering station, because yeah, that thing will chew the pads up. It's a lot easier to use iron. Yeah, this is like looks like a small like home etched kite board, so the traces are not doing too well. Although I can see where they are and where they're broken, so yeah, that's easy fix. So let's get the rest of these chips off and the sockets. They should just lift out now. Yeah, nice and easy. There is one trace running under there, as I suspected. Okay, so I will continue with this and I will be back with you in a moment. Okay, so we've got the board dismantled, we've got the chips removed, so let's just take a quick look at the chips. Okay, so we've got two 4066s, which are muxes. So they're obviously doing some switching, maybe something to do, well, it came from here and there, so probably something to do with selecting ranges, maybe, a resistor ladder. We have a CA3260E, this is a dual op amp, which, yeah, figures, that was here, so it's probably maybe buffering the inputs or the outputs, whether the inputs or outputs. We've got a 74C374N. This is an octal D-type flip-flop, so yeah, maybe that is buffering, maybe, I don't know. I think I thought maybe it was buffering the data bus, but no, it doesn't seem to be. So I'm not sure what that is being used for at the moment until we reverse engineer the circuit and get a better idea. And the star of the show is the ADC0803LCN. This is an 8-bit ADC, specifically designed to work with 8-bit microprocessors. It has a full 8-bit data bus, so it connects directly to the CPU's bus. And then yeah, and then you have here is an LM336 as a 2.5 volt voltage reference, which is for the ADC, and presumably this is a 5 or a 10 turn pot just to trim that voltage. We've got a few other miscellaneous components here, another little trimmer, some caps, some tag tants. This thing, I am not entirely sure what that is, but given its size and bulk, I think that's probably going to be a inductor, maybe. or it's some kind of fuse, maybe some kind of non-resettable fuse, because yeah, it seems to be, I think that's probably across a power rail. It did lift a couple of pads when desoldering this, because yeah, this is like a homebrew board. It is double-sided, but it's not through-hole plated. That's why you have these things here, these little pins going through to connect the two sides together. So the next thing to do is to reverse engineer this. So what I'll do is I will open up my favorite CAD package, which at the moment is Easy EDA, and then I will put all the chips in, put all the components in, and then start creating the schematic. I've got all the resistor values. The diodes are probably going to be just jelly bean diodes, nothing special by the looks of them. The resistors might be high tolerance resistors, 1% maybe, who knows. But yeah, I will get this reversed engineered and then put up the schematics online, so that if you want to try and build one yourself, then you can do. I presume the ADC is probably obsolete, but you should still be able to get them, I would think. Okay, so there we have it. So I will leave it there. This will be the end of part one. I'll do this a two-parter. In the next episode I will, obviously go through the schematic and do a bit of an analysis. But until then, don't forget to like, share and subscribe, and hit that bell icon if you want to get notified when the next episode comes out. For now, thanks for watching.